Hello, can you guys hear me?
The other one is the actual mic. That one's from the camera.
Oh, my bad.
Oh, you need both.
Oh, I need to hold both. Can I just leave that here? Hello? There we go. All right. Sorry, I'm just setting up my box. All right, everyone. Good evening. My name is Aleeza, and I'm a junior materials and process engineer at MDA, where I get to contribute to very exciting projects like the Canadarm3 for the Lunar Gateway mission that's happening soon. And I'm also an aspiring astronaut, and I'd like to take you on the winding journey that led me here. So it started off from a young age where I used to watch NOVA documentaries about black holes and nova clusters and all the cool stuff with my siblings, and also watching Cosmos by Neil deGrasse Tyson. And it was that sort of shift for me that really, really excited me about science and STEM. And so I wonder if you guys had the same experience where if you watched something when you were really young that sort of rewired your brain. But that was basically the case for me. And the moment that really solidified my interest in space was Interstellar. It was the combination, I see a lot of smiles here. It was a combination of the visuals, the sound score, and the storyline that really spoke to me, and it made space feel more personal and not just a dark void of nothingness that we don't understand, but really it was a very spiritual experience. And that led me to pursue my career. So ever since I started my university, I started to basically hone all my interest and my extracurriculars within the space-related projects. So I started off with Cassie, which this was me, very young, over there, going to space conferences and networking with people through the Cassie organization, which really highlighted the importance of meeting people in the industry and seeing what they're up to and networking and building your connections. It was a very important beginning chapter for me. And then there was other projects like AlbertaSat that I also worked on, which highlighted the importance of space system design. And in that project, we learned a lot about how the design phases of any space mission work. So you start off with a PDR, preliminary design review. There we go. And the CDR with the critical design review, and then you get to your final phase. And these are actually things that we use in the space industry right now. Any design that we go through, it goes through the PDR or CDR. So that project that I was part of was really, really helpful to learn more about how a space design goes through multiple different phases and how you actualize it and then send it towards launch. And then I also was part of the other projects, which were a bit more personal. So on the side here, that's me welding. But basically that is the reason why I have that there is I wanted to highlight the importance of not only doing theoretical projects where you're in groups of meetings and talking about design and maybe even doing some testing and helping with all that, but also to take some time to build things that you struggle with personally, the lessons that you learn on your own. And that was, I would go into the engineering garage, which is the makerspace at the University of Alberta. So yes, that's where I'm from. I'm from University of Alberta. I'm from Edmonton. And so in that, I would go into the garage, just build things. I would even do something as simple as making towels for my loved ones with their names on, and I would use the embroidery machine. So just stuff like that, using the soldering machine for the first time, using a lot of things that I didn't get to use in my undergrad because, as a materials and process, you don't really get to do all those things. So I deliberately went outside my comfort zone and tried to do things that would help me grow as a person. At the time, I didn't know that that was the intention. I was just eager to learn. And then the welding picture here is actually a group that a very close friend of mine started. It was a non-for-profit space where you learn how to weld, especially for women and people of minority groups, in a safe and supportive environment to learn trade skills. And so that's where I was actually working on that frame that you see is here as what's going to lead me to my next few points is some of the research that I was working on. So, okay. It's a bit hidden there with the title, but basically I started off then also my research projects. There are a few that I will talk about, but this one is the hybrid aluminum investment casting that where I was building diamond lattice structures. And in that, this was actually also part of my co-op research, which started off I should probably start with explaining what the investment casting process is. But basically in casting, when you see someone taking hot mold, pouring into basically a ceramic mold, and then you break it apart and then you get your shape. This was a similar idea, but instead of like wax being what creates the mold, it was 3D printed parts. And so we were researching how well that process works. And you start off with your 3D print, then you go on to the ceramic mold, and there were two methods that I employed. There was the ceramic slurry mold, and then the one that so it's not the dipping process, you actually have to pour it into an actual vessel, and then it solidifies. And then both of them are baked out, and then you get your lattice structure after the mold has been poured into it and it's been solidified. So the first one didn't go so well, and that was actually one of the processes that I sat down with my professor and I said, can we try a different product? And that's when we tried the ceramic slurry, and it was actually very disappointing because he had invested some money into getting this thing. It didn't work out. Very disappointing. And then we went back to his original method, and then you see this perfect lattice structure. That was not the case when I started this co-op research. It took almost 9 months to get to this point. It was we had changed a lot of things. So we were changing the ceramic mold. We were also changing the bake-out schedule. Things that are there actually any materials engineer here, by curiosity? Yes? Do you know what I'm talking about? Yes, perfect. Yeah. Okay, so basically in casting, as you know, that's a very, very hard structure to get. So I was very proud of myself when after the 9 months of trials and tribulations, sitting down with my professor, sometimes my professor even telling me, you're not doing enough. So to get to that point was very, it was a high achievement. And what I learned through this process was that even though I might make decisions that might lead to success, I might be asking dumb questions sometimes, or I might not have the support I need. These are all concerns that I need to be addressing to my professor or whoever, my mentor or something, to be able to just share my progress and then ask questions about what is missing, what can I get help with, and knowing what kind of questions to ask too. And if that leads to you start by asking dumb questions, whatever, it's fine. I mean, we're here, right? And they do say there are no dumb questions, but sometimes there are. It's okay. So then after that, I went on to do one of the most challenging thing in my, even now after still practicing my engineering, I still think this was one of the most challenging thing that I worked on. It was the Canadian Reduced Gravity Experiment in 2002. Me and my team were selected to research additive manufacturing in microgravity. Now, how would we do that? So once you have built your experiment, you have built your payload, you have 9 months to do so, and then you basically go on to a parabolic flight. This is the Falcon 20. It's the only one that we have in Canada right now for microgravity research. And I'm not sure if any of you know Shauna Pandya, Dr. Shauna Pandya? No? She's a super awesome lady, aspiring astronaut. She goes on this plane a lot to do some research. Very, very big figure in the Canadian industry, space industry. So going back to this, we go on to the parabolic flight. That flight has about 14 parabolas. And each time you go into a parabola, so you go, this part of the parabola is hypergravity for 2 seconds, 2g. And then on the top, you're facing about 10 seconds of microgravity, so about close to 0 to 1g. Back down, 2g, level flight. And that goes on for 14 times. And we call it the vomit comet. But I did not vomit, so that was great. So in this, basically you see my experiment here. This is the frame that I was working on earlier that I was welding, as you saw. And these are little, samples. And this is that iron powder over here. And we would eject into a binder that would then sort of create any, sort of clusters. And the idea was to research how well can you do this type of 3D printing, which is called binder jetting, additive manufacturing in microgravity, given that there's liquids involved, given that, the powder will sort of float. So the way we solved that problem was having a magnet underneath. And this type of additive manufacturing is actually very beneficial, just through the understanding, through the processes of how it works. It's, for metal, it's very good, and even ceramics, it works very well. So that's why we wanted to test it. But in this entire process, there were so many challenges. There were logistical challenges, there were financial challenges, staffing issues, and in this, right before, about 2 to 3 weeks before, I had to email my supervisor for this project saying that I don't think we'll be able to make it to the campaign. What are our options? I think we can forfeit because we just didn't have enough people. We didn't have a finished experiment. And that was, again, due to lack of support. And so they said that the SEDS Canada said, come down anyway, we'll see what we can do. So 3 days before the experiment, we're basically sitting down with flight engineers, researchers, and everyone who wants us to sort of, go on that flight and experiment. And they help us bring it to completion. So we went from an unfinished payload to finishing it in 3 days before the flight. And the end result, it was a success. So stuff like that is basically a lesson to your life that sometimes you just need to push. Even though you feel that you're not going to be able to get to the finish line, it is worth seeing something go through to the end and seeing what that leads to. And throughout this entire process, I learned more about leadership and resiliency than any classroom could ever teach me. And then, not long after that, there's a fun video to see if that will work. No, maybe not. I think in my original thing it works, but I don't think it's working here. But basically this video is just me floating into microgravity. It was supposed to be cool, but it's fine. So now this leads me to my recent thing that I've done, which is Project Possum. And it was a program that I was accepted in sort of right after CanRGX. And I got to learn about what it feels to be, sort of close to what it feels to being an astronaut. And this was a 7-day course in Florida. You get to learn about mesosphere research, human physiology in space environment, a little bit about space medicine, and a little bit about how to think and basically act in emergency situations like astronauts have to do, and also you have to learn situational awareness and how to work as a team as well. So it was a really great experience. And I mean, some of the cool things that I can share that I did in that was, this is me being on the aerobatic flight. This is different from a microgravity flight because this one does, I guess, aerobics. You go sort of in hypergravity as well, and you go in microgravity, and then like sometimes the plane is upside down, and sometimes the plane is, he even let me flew the plane for a bit, and he was like, do you want to land? I'm like, are you insane? I cannot land the plane. So it was a very fun experience. And then there was also a time where I got to wear the intervehicular suit, as you can see, IVA suit. And that one is, so this is not the white suit that you see. This is the one before that. So this is what they wear right before they're launching. And the reason why they wear it is if there's any pressure issues in the cabin, the suit can protect you from those pressure issues. And so the suit was actually regulated. And once I closed the glass top, I was actually, my ears were popping because they were controlling the pressure. And we were in a simulation where I could fly with my co-pilot, fly the rocket into mesosphere atmosphere. It was very, very, very interesting. And I think that was the moment for me, that and the CanRGX were the two big, like, solidifying moments for me that made me feel a very strong sense of clarity, that this is what I want to pursue. This is the stuff that I keep wanting to research. I want to help shape the future of space. And that is what led me to working at MDA. But before we get to that, one more research that I wanted to talk about was this Kevlar braided composite research that I also did in my undergrad. And this is a very special research to me because it was something that I actually went to my professor with the idea of. My professor was researching Kevlar, which is a material that's used in space, but he was researching it for biomedical reasons and for prosthetics. So I went in and I just said, hey, like, this is my research idea. Can I do some space environmental research on it? Can I study how the material would react in thermal cycling environment or radiation or something like that? And he said, yes, give me a nice long preliminary literature review, and then we can go from there. And then so that's exactly what I did. I researched a lot about the space environment. I researched about what research has already been done of Kevlar in space. And this is actually a material that's used in EVA suits, which is the white suit that astronauts wear. And it's also used in bulletproof vest that police officers wear. So it's a very, very shock absorbent material, very good for that. So this is what I wanted to learn. And the one reason I wanted to talk about this specifically is because this was a project that didn't exist. I went to my professor and I talked about wanting to do this with him because I had an interest. And I also saw that there was a lack of materials research at my university. And in Alberta, a lot of the materials that you research are for oil and gas industry. So that was my opportunity to go in and ask about, is this something that we can do? And again, don't be afraid to create opportunities that you don't think exist. Just go and ask. And dive into the difficult task. Even if you don't know, you will figure it out. Like I said earlier, sometimes it's worth it to see things to completion. Right, so now, where I'm at now. I work at MDA Space. I am a materials process engineer there. What we do is, so I do a couple things. This one that you see in front of me is the big one. That's the SSRMS, which is Canadarm2. So I help with repairing and maintenance of the arm. I get to work with a lot of different groups from different disciplines, thermal, mechanical, all sorts of things, and I get to help with a lot of cool projects. And then and then that's the SPDM, which is the dexterous arm, which is a smaller arm that does more smaller tasks that astronauts cannot do. And where we're headed is we are going back to the moon. We are as a Canadian industry, specifically with MDA, we're working on the Canadarm3, trying to have that up and running in a couple of years, I hope. And my coworker is shaking her head because space schedules don't work like that. But yeah, so hopefully you'll see me continue working on that and pursuing my dreams. And that's all I have to share for today. Thank you.
Questions?
Your hybrid aluminum casting research, was that the result published?
Ooh. Sorry, is that published? So I basically improved the process of how it's done. I think they don't necessarily want to publish the process. They want to publish the actual, like how the result of the material is, so the mechanical properties. So they would research the porosity of, the final product and such. And so that is research that's still ongoing. But as a student, I basically help to streamline the process. So,
And if you go to that slide with the alloy, I mean, my understanding of a structure is lattice structure is supposed to be microscopic, but this seems very big. What's?
Yes, that is correct. A lattice structure is microscopic, and truly, when you see it in an atom, you will not see it like this. But the idea was to see if the process can print complex things. That's why he picked the diamond lattice structure as well. And I think my professor also said that he wanted to see if that similar structure can be used for structural purposes, for pipelines and stuff.
So this is an example of the 3D printing of metals, right?
3D printing that can lead to casting of metals, improved casting of metals. But yes, there are 3D printing of metals.
Oh, okay, so the final shape is not 3D printed, but okay.
Yeah, the final shape is not 3D printed. It's hybrid casting.
Hybrid, okay.
Yeah.
I guess, is that...
Sorry, we're going to give a chance for some more questions, but feel free to chat after. Love the discussion as well.
Yeah, thank you for your questions.
Any other questions? Some other arm. Never mind, please continue.
That's is this an example of additive manufacturing?
I would say so. Yeah, I would say so because the initial print is additive manufacturing. So this is kind of hybrid casting that involves additive manufacturing. Yeah.
Okay.
Yeah.
Okay, thank you.
Thank you.
Okay, any other questions? Sorry to cut you off there. Okay, awesome. If there's no more questions, we will take a quick 5-minute break. Get our online speaker. Thank you again, Aleeza.